All right. Hey, so guys, why don't you let me lead the process here for a couple minutes? Simply because there are some things that I think you're going to benefit from as we look this assignment over, especially relative to the fact that we're getting quickly to the test, right? So guys, today we're going to do a lab. When I see you on Wednesday, because no school Monday, we're going to be back in lab for a stations activity, and then Friday is going to be the test. So guys, 2 of the next 3 days are going to be very active. You've now learned all the new material for this unit. So really over the next couple days, we're just going to sort of polish things, and then we're going to do the test on Friday. So guys, looking this over, this was not a coincidence that the first, and maybe say it bigger, all of these questions were clustered together. And guys, the hope was that because you were seeing the clustering, it was making you proficient at the different types of problems you need to solve. So guys, numbers 1 through 4, you were solving for concentration or molarity. Molarity are the units for concentration. Guys, notice that your starting points were always the same. You're always starting in mass over volume, and then it's always a 2-step conversion. You're converting mass to moles, you're converting milliliters or centimeters cubed, which are the same, over to liters. Guys, same thing over and over and over again. So any questions about that process? Y'all good? Okay. Then guys, number 5 is sort of hanging out at the bottom. Let's let that be, and let's let 6, 7, and 8. But guys, understand number 5 should be a part of this conversation because 5 through 8 were also a clustering of problem types. What do all these questions have in common? And guys, the answer is you never start with molarity, right? You're going to remember that on the test, yeah? Guys, you never start these questions with molarity. Notice that the molarity is here, and the molarity is there, and the molarity is there. Because, guys, molarity is our conversion between moles and liters. So we'll start with the other information we're given, whether that's a volume or whether that's a mass. And then molarity eventually becomes a conversion that we're going to leverage. So, guys, any questions about those? Y'all good? Okay. Then, guys, the last one, and we're going to dwell here for a minute. Guys, when you look at these, you're looking at the calculations that you're going to do in your labs today. So, guys, when you go to write up your labs, make sure you have these in front of you, because literally these are the calculations for your lab. The only difference is the masses you're going to measure in lab, they're not going to be given to you. So, guys, any questions about this? Really? So that means you guys can all explain to me what's going on with number 11? Or should we talk? Let's talk about number 11. So guys, here's the deal. Looking at 9 and 10, when we divide by the smallest number of moles, divide here, we end up with numbers that are almost perfectly whole numbers. This is exactly 1. That is so close to 3 that we're just going to call it 3. This is exactly 1. This is really, really close to 2. But guys, here's the problem. In number 11, when you do this division, it ends up almost exactly at 3.5. So close that to round it down to 3 or up to 4 would not be appropriate. So guys, what we do is we keep the 3.5 and then we double everything, and that maintains the ratio, and it becomes 7 to 6 to 2. So now you're thinking, how on earth am I supposed to know when to round, and how do I know when to keep the decimal and then multiply? And guys, the answer is this. These numbers are either going to work out almost perfectly to whole numbers, or you're going to get something that's almost exactly a 0.5. Then double everything. The only other thing that you could see is you do the division and you get a 0.33, and then you triple everything. You won't see anything other than that. So, guys, questions about anything on the homework? You guys okay? Yeah, so the idea is this, that when we do this division, this is the ratio of elements. So it's 3.5 to 3 to 1. But you can't write a chemical formula from that, because you can't go 3.5 to 3 to 1. That doesn't, we can't have decimals. So what we do is we double everything, and when we double everything, we maintain the ratio, but then we have whole numbers. Is that okay? What else, y'all? You guys good? Okay, so I would suggest you maybe not put your homework away, because guys, this lab goes really fast. It's like 25 minutes to collect your data, and then you're going to be done. So you're going to have time to write this up today. So maybe just slide, especially these calculations, to the side, because you're going to want them as a reference when you do your calculations. Guys, this is the lab. All you need then is a pencil. You don't even need periodic tables and stuff. You just need something to record your data with. And we're going to go over this, and then we're going to get you next door. Here we go. Let's do this thing. Okay. Hey, so we're actually going to be in lab. Do you want to go to Miss Call's lab? That'd be great. Just walk through the break there. All right. Okay, so guys, oh wait, also, don't forget to set a reminder, right? Midnight tonight, record this homework assignment. It goes on fourth quarter's grade, but it does go on fourth quarter's grade. So guys, make sure that you record this before midnight tonight. All right, so that goes away, this comes into view. Okay. So, guys, reading the title of the lab with... Oh, wait, we should do this first. Guys, the lab is not due on Tuesday. This lab is due on Friday. Here's why. I've had people that are coming to me at the end of the quarter, and they're going, hey, Mr. Knappenberger, can I redo labs? And, guys, the answer is always no. We don't rewrite labs. When we turn them in, it's your final product. But guys, very, very few of you are bringing labs in to ask me to edit them ahead of time, and I'd love to do that with you. So guys, I'm giving you an extra 2 days, so if you would like me to edit this lab before you turn it in, you now have even more time for that. So guys, these are not due until Friday. So, with that said, gang, read the title with me. Not surprisingly, what are we doing? An empirical formula. Guys, let me explain to you though, and don't write any of this down, but watch. This isn't me just chatting. Guys, this is the lab in a nutshell. Here's what you're going to do. You're going to go into lab and you are going to grab your crucible. And guys, we haven't used one of these before. It looks like this, remember? Made out of ceramic, really heat resistant. And guys, what you're going to do in lab today is this. You're going to take a piece of magnesium ribbon. It's element number 12 in ribbon form, and you are going to tear it up into little itty bitty pieces. And guys, you are going to put all of those magnesium pieces in the bottom of your crucible. But remember that where we're going is we want to calculate the empirical formula, right? So what data do we need about that magnesium in order to be able to do an empirical formula calculation? Look at your homework if you don't know. Guys, what data do we need? We need to know the mass of the magnesium. But guys, the magnesium is already in the crucible, so we can't weigh it. So what do we need to do first? Weigh the crucible. So guys, we're going to weigh the crucible, then we're going to put the magnesium in the crucible, then we're going to weigh it again, and eventually we can do the subtraction to get the mass of the magnesium. Then guys, what you're going to do is this. You are going to set up your ring stand. And guys, please be really careful about how you do this, because a lot of my first period students yesterday didn't pay attention to this and their labs didn't work. So guys, here's what you're going to do. Imagine that this is my Bunsen burner. So guys, what you're going to do is, well, first of all, you'll notice that on your ring stands, there's one of these. I took off the metal mesh and I replaced it with this. Guys, this is actually what's called a clay triangle, and it supports your crucible better. But be careful, because for many of you, your crucible will actually fall through the clay triangle and break. So guys, what you want to do is adjust it by bending this leg until it's supported about in the middle. Now guys, this is the mistake my kids made yesterday. When you adjust this, what you want to do is this. You want to leave about a 2.5 inch gap right here. If you get this too close to the Bunsen burner, this lab will not work. I'll explain to you why in a minute, but if you get this too close, it won't work. So you need about a 2.5 inch gap here. Guys, if it's clear up here, it's not going to work either. So there's this sweet spot right about there. If you're not sure, come and talk with me. But guys, you need to adjust it like so. Then what you're going to do is you're going to cook the bajinkers out of this for 15 minutes. And guys, when you do, here's what's going to happen. There's all sorts of oxygen out in the room surrounding this magnesium. And when you cook this, the magnesium is going to jump down into the crucible and it's going to react with the magnesium. What did I say? Oh, the magnesium. No, the magnesium's not going to jump. Sorry. The oxygen is going to jump. It's going to flow down into the crucible and it's going to bond with the magnesium. Because I was sort of thinking ahead to how to explain this to you. So let me try this now. So why is it the lab would not work if the Bunsen burner is too close to the thing? Yeah. Exactly. The flame uses up all the oxygen and none of it can get into the magnesium. So guys, that's why you need to leave a little gap here so that the oxygen the flame is burning is not the same oxygen that the thing's trying to react with. So anyway, guys, you're going to cook this for you're going to cook it for 15 minutes. When it's all done, all of this magnesium down here is going to have reacted with the oxygen. At that point, you shut everything off, you let it cool, you go weigh it again, and you're done with the lab. Now guys, here's the question. When you weigh this again at the end, will it weigh more or less than it did when you weighed it the second time? Why more? What made it heavier? The oxygen. Do you get the idea? Okay, so guys, with that said, grab your labs, read the procedure with me. Make sure that this makes sense. Step 1, clean the crucible. Guys, but notice what it says. Clean the crucible by carefully scraping out as much of the residue as possible and wipe it out with the paper towel. Guys, this crucible I did the lab in yesterday for the video. Guys, look at the bottom. It's a mess, right? This will not come out. It's permanently fused to the crucible. So when you get this crucible, you just want to scrape it a little bit, get out the big chunks, tap it out, wipe it out with a paper towel. Anything that won't come out gently will not come out. Now guys, yesterday, first period, it was kind of a weird day. Yesterday, first period, one of my students' groups decided they were going to do a thorough job, and they ran it under water, and then they washed it out. And then when they put it on the Bunsen burner, the water boiled and this thing exploded. Guys, if you turn on the water tap today during lab, you screwed up. You never need water in this lab. Guys, wipe it out, don't wash it out. Then guys, continuing on, step number 2, measure the mass. Step number 3, tear up the magnesium. Step number 4, put it in the crucible. Step number 5, weigh it again. Step number 6, heat it for 15 minutes. Is this all making sense? Okay, then guys, notice what it says. After 5 minutes, give it a look. If nothing is changed, come and get me. We can encourage the reaction to happen. Then guys, after 15 minutes, shut off the burner, let it cool, weigh it again, put it in the trash, you're done for the day. Good? Okay, now guys, with that said, I think we need to do some remembering about some things that you learned previously in the year that we haven't done in a while. Guys, go down and look at your calculations. Find the mass of the magnesium. Now look at your data. How are you going to find the mass of the magnesium? You're going to subtract. But guys, please remember, there are accepted ways to structure these calculations. So it goes something like mass, crucible, and magnesium minus the mass of the crucible gives us the mass of the mg, and then we're over here with our numbers and we're putting units on things. Guys, you know how to do this. I know it's been a while, but that doesn't change the expectations. Do this well. If you don't know how, ask. If you just take a shot at it and do what you feel is right, it's probably wrong. Do this well. If you need a reference, go back to our previous labs this year. Okay? Then guys, once you've done that, calculation number 2, you're going to figure out the mass of the oxygen, which is also a subtraction. Right? So guys, calculation number 2, we're going to go back and figure out the mass of the oxygen. Then we're going to take all of that information, flip the lab over on the back, and you'll notice that you've just got a big old white space, right? What you're going to do there are the same calculations that you did in homework. Then guys, please be careful. I'm going to be grading your conclusion questions very carefully. You have literally a week to do this well. Start fourth quarter out well and invest in this. Guys, I'd love to talk with you about any of this that you need, but that's what we're doing in lab today. Do you have any questions? Do we have any, Matthew, are you Matt or Matt? I hear people calling you Matt now, but you introduced yourself to me as Matthew. Okay, so do you have a lab? You guys are a lab group, right? You guys are good? Does anybody else, we're lab groups are good, right? We're okay? Goggles first. We'll see you next door. Let's go, you guys.